Hello, Luke.
Hey, how are you?
Excellent. How are you today?
I'm good. Still raining up here, but
Is it?
yeah.
It's bright and sunny down in Columbus.
Oh, is it?
Yeah.
I have family in Delaware.
Oh, okay. How things go for you with the exercises?
Good. I think there's maybe one or two questions that I was not 100% sure on, but I think I got them all.
Okay, good. Excellent.
Because like there's like, how you define DevOps or something. But I know
Uh-huh.
there's like to define DevOps and stuff. I know the definition. I might have overkilled it, like put too much in there, but
Well, that's fine. Welcome back, Amanda.
Thank you. How are you doing?
Excellent. Welcome back, Aman. Yeah, looks like your mic's on.
Hey, John, how's it going?
Good, good. So Daniel said he might be a little late, so let's go ahead and get started. Thank you all for joining promptly. yesterday we covered some basics of DevOps, and then we left with some exercises to do in preparation or to refresh ourselves as to what we learned about DevOps yesterday in the basic section. And then today, we're going to begin by reviewing what you came up with for the exercises. And then we'll get into Unit 2. And then I've got a special treat, if you will. We've got a video that's about 13 minutes long from Spotify. And it's a video that talks about the evolution of Spotify, but they were one of the earlier adopters of DevOps. And so it will give you a great idea as to some of the kinds of things that companies go through as they evolve toward DevOps. Now, they had an advantage because they were starting to do DevOps when they were a startup organization and pretty small. So there will be some other challenges if you join an organization that's been around for a while, but students have found this video to be very helpful. And then there's a second part to the video, and we'll watch it at the end of tomorrow's session. But with that background, any questions that maybe you have? Okay, hearing none, what I'd like to do, Daniel sent me his answers. So what I'd like to do is go through the and give everyone a chance to share their answer for the questions, and then we'll see what we can learn from the exercises. So Amanda, if you would start us out with the first question, which was to write down the Agile Manifesto. Do you mind sharing your answer to that?
Yes, I had the, let's see, individuals and interactions over processes and tools, working software over comprehensive documentation,
Mm-hmm.
customer collaboration over contract negotiation, and responding to change over following a plan.
Excellent. That's exactly right. So very good. Aman, if you would take question 2, how have developments in virtualization and cloud computing impacted the computing landscape?
Yeah, so virtualization has made an impact by efficient use of hardware and additional level of abstraction between business applications and system software.
Okay.
And cloud impacting had impact due to VPN, with VPN to send private data over shared channels with security, privacy, and quality of service. And large providers were made virtual resources affordable and reliable.
Okay. Very good. Very good. So I don't recall, did you mention the enabling managing infrastructure as code?
No, I did not.
Okay. That would be one other thing you might include in your answer. Then Daniel had question 3 to define DevOps, and his answer says DevOps might seem like just a continuation of agile software development, but it basically builds on top of it while further enhancing it and incorporating modern IT technologies as well as lean manufacturing into it to make IT and business teams work together on a daily basis in order to provide value. So now the book definition, if you will, is that DevOps is an evolution of the ideas of agile software development and lean manufacturing applied to the end-to-end value chain in IT which allows businesses to achieve more with modern information technologies due to cultural, organizational, and technical changes. So Luke, if you could do number 4, we've got a number of true and false questions. Indicate whether each of the following is true or false. Number 1, DevOps is meant to replace agile and lean practices. True or false?
False.
Good. With DevOps, the IT department together with the business need to think about the whole value chain. True or
True.
false? Okay. The expected value from using DevOps lies in greater return on information technology.
I have true.
Okay, that's correct. You're batting 1,000 here. Number 4, the 3 essential elements of DevOps are cultural, organizational, and environmental means.
And I have false. It's cultural, organizational, and technical means.
Okay, very good. You caught it. Very good. Now, we'll continue with the questions here in just a moment, but I wanted to point out that for the purposes of the exam, these are not exam type questions. There is a sample exam that will have exam type questions, but these are were created to be a learning document for you to help you review the material and try to synthesize what we learned yesterday. So Amanda, we're back to you. Number 5, define value stream. We're not hearing you. If you
Okay, yeah, and I'm sorry, I was looking.
That's
for it.
okay.
Let's see, I have steps to get the job done, actions performed to fulfill the query are lined up in a sequence.
Okay.
I think that's all I had.
Okay. So the book answer to this one is that the value stream is the sequence of actions performed by an organization to create value in response to a customer's request. And I think you had most of the elements of that in your definition. So very good. Aman, number 6, what are the steps of the value stream mapping exercise?
The first step is to identify the key steps of the request processing.
Mm-hmm.
The second step is to document the work performed at each of them. The third step is to arrange these steps into a sequence of creation of the desired outcome.
Very good. Excellent. Then number 7, what are the 3 main benefits of value stream mapping? And here the answer is to create a sobering effect on the participants of the process, to focus on the created value rather than on the actions being performed, and to identify and eliminate bottlenecks. Then number 8, Luke, what benefits can DevOps deliver in terms of return on IT?
I have accelerating the delivery of new modified products to the market, quicker response to the customer needs, improved availability and sustainability of IT systems, and more efficient use of limited resources.
Okay, very good. Then number 9, Amanda, what are the 3 reasons for using DevOps?
I'm gonna have to step away for a minute. I
Okay.
apologize. Okay, thank you.
Sure. Ahmad, would you take that? What are the 3 reasons for using DevOps?
Yeah. The first reason, some management frameworks emerge as a product of the author's imagination. So having a theoretical approach, uh, their applicability or inapplicability is proven by adherents and followers trying to use new techniques in their work and managing others. And other approaches are born as a response to quite pressing needs.
Okay. Okay. The book
And
answer.
I got a different answer for, is that number 9?
Yes.
I got decreased time to market, reduce technical debt, and eliminate fragility.
Okay. Those are the 3 that are the book answer.
Okay.
Yeah, decrease time to market, reduce technical debt, and eliminate fragility. Okay, then number 10, what are the DevOps techniques for reducing time to market? And it's to reduce the batch size. It's to reduce the number of handoffs. It's continual identification and elimination of losses. It's self-sufficient teams and automation. Amanda, are you back? Okay, if not, Aman, would you take number 11? What practice does DevOps recommend in order to prevent stagnation of problems?
Facing the issues as frequent as possible.
Okay, very good. Then number 12, what is the DevOps practice for combating fragility? It's the deliberate introduction of chaos and instability into the production environment. Then number 13, Luke, would you take it? Mention 3 common myths around DevOps.
DevOps is nothing more than the continuation of agile ideas.
Yeah.
Tools will provide you with the very DevOps.
Okay.
And DevOps is a universal soldier able to code and create tests, to deploy environments, and to manage infrastructure.
Okay, very good. And then number 14, did any of you have some perspective on that? I know you, none of you had any experience with DevOps before. So what did you have anything to share on number 14?
I've just heard it's a continuation of agile before. I've heard that one.
Okay. Okay. So that was your perception
Yeah.
of what it was. Okay. And to a certain extent it is, but it's much more than that, as we learned yesterday.
You know, before starting this course yesterday, I didn't know what to expect from DevOps.
Okay. And that's fine. We're all here to learn. So, and as you answered the questions, you've obviously at least learned where to find the answers. And hopefully that's been helpful for you as a review. So any questions that may have come up from going over the questions and the answers, or any questions you may have from yesterday?
Not questions pertaining to the thing, but were we supposed to send them to you, or is that just because he's not here?
That's just because he isn't here.
Okay, cool.
Yeah. Yeah. Yep. Nope. This is for your benefit. So, and we review the answers in class. So if you had any that you had a different answer, you can, learn more about it. So, well, today we're going to be looking at some DevOps principles. And there are 5 of them that we're going to look at as part of our lesson today. So we're going to begin with value stream. Now, we heard about value stream mapping yesterday, but we're going to be looking at it in a little more depth because having a good value stream is key to successfully getting the value from DevOps. Now, this value stream, first of all, is pretty small and complex, but it's a pictorial representation of the process that organizations usually followed before DevOps. So it's the waterfall process. And a couple of things you'll notice is that there's a line down here about halfway through, and above the line is the part that was historically called development. And then below the dotted line are the steps that were typically attributed to operations or deployment of the software. So there isn't any particular intelligence to this diagram, but let me point out a couple of things. First of all, when you're truly doing value stream mapping, ideally, remember we wanted it to be the key steps. So we'd like to have fewer steps than are shown here that we're working with. And the idea is that rather than getting into the nitty-gritty of processing, the process steps, we're trying to step back from it and say, what are the keys to being able to deliver value with a new application? Might be a way to say it. So you'll note with each box, there's a description of what it represents. And then below it is the lead time, then the processing time, and the percent complete and accurate. And then down at the bottom, we see here where we've totaled up the lead time and the processing time. We've looked at a ratio between processing time and lead time, and it says 18% if I'm reading it correctly. So what that's saying is of the lead time and processing time, we're only doing work 18% of the time of the elapsed time. So that's not good. That means we're taking too much time if we're going to be efficient and effective in this value stream. And then you see the total percent complete and accurate, and it says 2.9%. So that means that only 2.9% of the time that we go through all of these steps have we done it correctly the first time. And so that means that there's, again, a lot of times that we had to go back and redo steps. And in case you're curious, the total percent complete and accurate is calculated by multiplying the percent complete and accurate of each of the steps. So that's how you arrive at that number. That's kind of a gee whiz thing at this point, but I just wanted to mention that. So this is a pretty complex value stream map if you were to have created this on your own. So when we're creating a value stream, then we need to think about the organization and how it creates value based on what it is we're trying to deliver to our customers. And so we want to line up the actions that we need to take into a sequential list. The value stream you saw is a pictorial representation. We would want to do that. Sometimes that's done on a whiteboard with sticky notes. Sometimes it's done on a piece of paper, much like the one that we just saw. But the idea is for people to visually think about what are the steps that we follow in order to deliver value to our customers. So now we looked at one value stream. Typically, there are lots of different value streams in an organization. So, for example, responding to customer help desk inquiries would be another value stream. So there will also, there could be a different value stream potentially for each of your products that you have. You may go through a number of different steps. Although ideally you'd like, when you're doing something like creating value for your customer by delivering new functionality, as much as possible, you would like for each of the different applications to go through the same steps. So here's another look at a value stream. This one begins with the customer at the top in the middle. And you notice that the next step is to what we call ideate. And what does that mean? It means planning the product. Once we've completed the planning of the product, then we create the product. And this is where we do the engineering and the testing of the product. The third step, once we've completed that, is we release that product and make it available to our customers. And that is called release management. And then the fourth step is to operate. So we've released it, made it available to the customer. Now we need to keep it working. And that is what we refer to then as support and monitoring and operations in IT. And then, of course, we have a feedback loop that goes back to the customer. And that's because we want to get feedback from them to what else we might include in the product. And so as we gather that, then we would go through the sequence again. Now, we've just for illustration purposes, we've also shown which of the steps we would have had in a lean manufacturing context. And so in a manufacturing context, you need to begin by creating the product. Then you need to make it available to your customers, and then you need to maintain the product. So those are the steps. Again, if you like to think of things from a pictorial perspective, that's what we're trying to achieve. So we mentioned value stream mapping yesterday, and we mentioned creating the as-is picture, but the second step of value stream mapping is to create a to-be picture. So when you initially create a value stream map, you're likely going to find that it's not producing the best value, that there are steps that maybe aren't necessary. And there are steps that there's too much lead time between the steps. And so the idea of the to-be picture is to create a vision for the way you would like to create value for your customers. So two different pictures. One's the before, the other is what you would like to become the after. So there are three metrics that you would like to attach to each of the steps in the value stream. You'd like to have the lead time, the processing time, and the percent complete and accurate. So for the purposes of the exam, it would be good to know that these are the three metrics that are used with value stream mapping, because you may find a question on the exam that would have each of these as answer one, answer two, answer three, and then some other answer for number four, just for example. So on the exam, there are both positive questions and negative questions. So the question here might be, which of these is not a metric for value stream mapping? So after we've done value stream mapping, there are some questions that we usually need to consider and think about how to answer. The first has to do with the percent complete and accurate. And you might ask, why would we demonstrate some work steps, percent complete and accurate values lower than 100%? And how can we achieve complete absence of errors transferred from one step to the other? So the first part of the question, why are the values lower than 100%? Because we would only get 100% if every time we completed that step, we never had to go back and redo that step, because we did not deliver everything that the next part of the value stream needed in order to complete their task and their step. As to the question of how can we achieve complete absence of errors transferred from one step to another, it's by doing the job right the first time and every time. So you may have had some experience in a job, doesn't have to be an IT related job, but a job where you were under pressure to perform certain tasks, and more than likely you delivered it right most of the time, but sometimes things would happen that would cause you to not deliver it correctly. Well, that's the whole concept of what we're trying to achieve here. So you could do value stream mapping in any context. You can even do it in your personal life. You know, what are the steps that we need to take to clean the house, for example? And, you know, if for example, someone didn't check the vacuum cleaner to see that there was room for additional dirt in the vacuum cleaner, then any step that involved using the vacuum cleaner would not have been 100% complete and accurate, because the vacuum cleaner wasn't picking up everything that it should have, because the bag was full, just as an example. So the second metric, lead time, the question there is, what exactly contributes to the lead time apart from the creation of the product? And how can we radically reduce time lost in queues and waiting? So a couple of aspects to that question. The first is what contributes to the lead time is often time lost between handoffs. So for example, if I'm responsible for step 1 and you're responsible for step 2. But when I complete my step, you may not be ready to pick up what I give you and immediately begin um, answering it or doing your part of the process. So the other aspect to it is oftentimes, particularly in IT, we have inserted in the wait time the need for approvals. So for example, I did my work, but before you can pick it up and do your work, someone has to review my work and approve it. Now, that may help us in terms of giving it right back to me if I didn't deliver it accurately. That would be a positive instance, but the fact that it needs approval probably means that there's a delay. And so that becomes then part of the lead time. So then in the processing time, the question here is how can we change the working practices to reduce the processing time at each step? So, here we're looking at the work that's actually being done in that value stream step. And we're looking for ways to simplify the work in order for it to take less time and yet still be accurate. Because if it isn't accurate, then our percent complete inaccurate is going to decline. So what questions might you have on these questions for value stream mapping? Those concepts make sense?
So far, so good.
Okay.
Can you go over the first part of the number 1, please?
Okay. Why demonstrate some work steps are with values lower than 100%? Is that the part?
Yes.
Okay. So in order to be successful with our value stream, we need to do the work correctly every time. But often that is not the case. And so if we did it accurately each and every time, then the percent complete and accurate would be 100%. But as we have instances where we do not do it right the first time, then it reduces that percentage of how often it's complete and accurate. And I mentioned on the prior slide that when you're trying to calculate the total percent complete and accurate, you want to multiply the percent complete and accurate values of each of the steps in your process. And in the slide here, it showed only 2.9% of the time did we actually complete the work correctly in each and every step as we went through that process or that value stream. Does that help, Amanda?
Yes, yeah, it does. Thank you.
Sure, you're welcome. So another way of saying it, just to add a little bit more, is if the value is 90%, then that means 9 times out of 10, when we go through this value stream, we will do it correctly, but there's one time when we won't. So here's another value stream for delivering software that is more like what we would use in a DevOps type of context. Now, it's not strictly meant to be a comparison to a waterfall project, but it's to show you that ideally you would have fewer steps and you still want to collect all of the metrics. But even here, we see that the lead time is 10 weeks, while the value added time is 7.5 days. So we're doing a lot of waiting in even this process. Now, our percent complete and accurate is up some compared to the prior example, but that's the idea of what you want to achieve with value stream mapping. When we talk about flow, and I mentioned the example of a river flowing or a creek flowing, we talked about we wanted to eliminate bottlenecks because there's usually, well, there's one and only one step of what we do that represents a bottleneck at any point in time. And what we'd like to do is eliminate that bottleneck. And once we complete that bottleneck or eliminate that bottleneck, now there's likely going to be some other place in our value stream that becomes a bottleneck. But the bottleneck is always the step where you lose the most momentum. And so that presents then the best, if you can simplify and correct that issue, then you're going to provide better value to your customers. So now we're going to look at how value stream mapping and optimizing our processes in the business and what it is that we do with the to be and the as is map. So when we want to do value stream mapping, we want to choose a product. We want to look at a product that seems to have issues and then represents the greatest opportunity to make quick improvements. Once we do that, once we've selected the product, then we need to create the as is as well as the to be map. And there are two reasons for that. First, it helps us to avoid local optimization. So what does that mean? If you have a value stream to be value stream map, and maybe you're responsible for the third step in the value stream, well, you could say, well, okay, currently it takes me a week to perform my step. What changes can I make to reduce the time in my step? Well, if we just look at your individual step, that's much like what IT has done in the past, in that with a waterfall project, oftentimes the different steps in a project were completed by different teams of people in the organization structure. And so each of those teams then had a supervisor or a manager of the team, and they would be looking for opportunities to reduce the budget that needed for that team. And so they may do some things that would simplify their work, but it may have a downstream implication for the people that receive their work. So we want to avoid local optimization where we're only looking at one piece of the value stream. Secondarily, we want to understand where it is we want to end up, and identify realistic improvement initiatives in order to simplify our 2B map, or to get to our 2B map. So just because you have an as-is map and a 2B map doesn't help you get to the 2B. It just shows you where am I trying to get. Here's where I'm starting from. Here's where I'm trying to get. Well, now we need to come up with different initiatives, and there can be multiple initiatives that help us get from the way we do things today to the 2B map. Any questions on that? So now I talked earlier about, you may create a value stream map for cleaning your house. And if you've got family members and different people are responsible for different pieces of the steps in your map, I mentioned that, if the vacuum cleaner bag is full of dirt, then it's not going to perform the step of vacuuming like it's expected to do. And so you're going to have a lower percent complete and accurate. Well, you can also have, look at the way your team, your family cleans the house. And maybe, for example, you run the vacuum cleaner first, and then you dust later. Well, the vacuum cleaner or the dust may then be throwing that dust back onto the carpet or the floor that you just vacuumed. So that would be another example of where you have the steps out of sequence. And so you can use this technique both in your personal life as well as your business life. If you are working in a fast food restaurant, they have a sequence of steps that they use for creating the food that is ordered. And you can use this same technique in that environment as well, to try and discover a better way of creating the orders for your customers so that you can deliver them faster. So we need to remember that in order to map the as is, we need to study what's actually being done rather than documentation of or guidelines of what is supposed to be done. And that's because oftentimes organizations will have a theoretical way the work gets done, and that gets documented. And that documentation is given to employees to, this is the way we want to do our work. But then reality sets in, and the employees may find their own shortcuts, if you will, to the step that they're involved in. So it's helpful to make sure that you're actually recording what's actually being done. Now, the Japanese and with the Toyota production system call that walking the Gemba. So that means that rather than sitting in a conference room and using documentation to create your as-is map, the team goes around and actually sees what people are doing and then documents what's actually being done, as opposed to the theoretical of what people think should be done. So some challenges that people have in doing value stream mapping is to get into the weeds. get into too many details. So one rule of thumb that you can use with value stream mapping is if your map doesn't fit on one piece of paper, without making the boxes tiny, then you've identified too many steps. So it's important that as a group works on a value stream, that they agree on what the steps are, who performs the work in those steps, and how the work is being performed. So when we apply value stream thinking then to DevOps, what are the results? Well, first of all, you could see in the upper left here, we need to understand where it is we're starting. So we've got some key metrics that we've been talking about. And as a result of that, oftentimes there will be an aha moment that the team members will have where they realize that, wow, this is what we're doing today is really pretty ugly. There has to be a better way. So then we apply focus to it and create a value stream map. And notice that in creating value, we want to be focused on the actions of why things are done as opposed to what is done. That's one of the differences between process mapping and value stream mapping. In process mapping, people are using the what, what is it that I'm doing? But if we're focused on delivering value to our customers, it's the why that we want to use and ask about, because maybe we don't have a good reason why it needs to be done, and therefore it could just be eliminated. So after understanding and focus, then we need to identify what bottlenecks do we have? Do we have local optimization that's been done? And here we mentioned the theory of constraints, whereby we really want to optimize the value stream as a whole, or the find the item that is causing the most delay. And that's what the theory of constraints talks about, is that there's only one step that's truly constraining all of the other steps at any point in time. Now, once you fix that step, now there may be another step that becomes a roadblock. So, and when I think of like a creek, oftentimes there may be a log across the creek, and that slows up the water, and the water backs up behind the log until there's enough water that the water will run over the log. Well, if you pick up that log and remove it, now you are allowing that creek to flow better. But there may be another area in the creek where you've got some big rocks. And so now that you've removed the log and got the flow working better, maybe the rocks can be removed or moved around so that they don't impede the flow of the water. That's the idea behind this value stream mapping. So our last step then is to understand and realize the value from having gone through this value stream mapping. And the idea that we're trying to achieve is a smooth and uniform flow from step to step with continuous delivery. Continuous delivery is a term in DevOps that means we're regularly producing output of value to our customers. And the idea is to do things rhythmically without unnecessary delays and with optimal resource utilization. So another example I can think of that's not IT, but may help you understand the concepts of what we're trying to achieve with value stream mapping is in a city, they've got roads, and where there are intersections between roads, oftentimes there are stop signs. So when you're approaching that intersection, if you see a stop sign, you're required to stop before proceeding through the intersection. Well, that's stopping your flow. There are intersections where there are four-way stops, and that just simply means from a flow perspective that everyone that's going through that intersection has a bump in the road, if you will, or has to slow down because they have to stop before they can proceed through the intersection. Now, we also use traffic lights, and now some of them are becoming sophisticated that they can detect when someone is coming from a direction, and maybe the light changes because someone is coming from a direction and there isn't anyone else detected near the intersection. So, but there will be times when people need to stop because they have a red light. Other times they can go through. Well, if they can go through, that's the better flow, right? Well, the third illustration is where we have a traffic circle. And the idea of the traffic circle is to increase the flow through the intersection. So people only have to stop if there truly is a conflict. So, you know, so the idea of the traffic circle then is, unless there's a conflict with another vehicle that's already in the traffic circle, you can go ahead and keep going through. So the idea is that you want to be able to flow through the intersection much more frequently than you could with a stop sign or with a traffic light. So I've said a whole lot about it. What comments or questions might you have? Well, hearing none, you can apply these same techniques in your job or in your personal life. Think about, things where you often have to stop or you're interrupted. And for example, if you're studying and someone is interrupting you while you're trying to study, well, that's going to slow down your flow or your ability to finish the study work that you need to do for your classes, for example. So that's the idea behind value stream and value stream mapping. So some other things to learn from value stream thinking is that the exercise of creating a map and understanding the as is values and the key metrics often surprises the people that are looking at the value stream. And the reason for that is that most people are heads down and they perform their function and don't think about what the other components are of the value stream. So while they may have an aha moment of, wow, I didn't know that was actually happening. Even if that's not the case, they will usually understand that there are some points of inefficiency in what is being done today. But by looking at the value stream from end to end, you're able to see how many deficiencies there are in the work that's being done, and to see it numerically. So when we looked at some of the examples earlier, we saw that we were spending more time uh, in lead time than we were in processing time. Well, that's pointing out inefficiencies. So as you're developing a 2B map, you want to look for, can I eliminate or reduce the amount of lead time between my steps? And the third bullet simply points out that visually looking at the process helps people to focus on value rather than on the steps that are being performed. Because if you just sit down and talk to someone in the organization that's maybe another step in the value stream, they're likely going to bring up, what it is that they're doing so that they are demonstrating they're providing good value to the organization, as opposed to thinking about what their contribution is to the delivery of the end product. So that's illustrated then by employees and managers tending to see and understand their daily tasks, but not understanding what outcome you're trying to achieve. And it's the outcome of the steps that you take that delivers value to your customer. So the value stream map then helps you identify and eliminate bottlenecks and avoid the local optimization trap. So, and in the third bullet, we're reminded that in conjunction with the theory of constraints, there's really only one bottleneck in any system at a single point in time. So the idea then behind DevOps is to create a smooth and uniform flow from step to step that allows us to deliver outputs continuously and rhythmically without unnecessary delays, and with optimal resource utilization. So that's what we're trying to achieve. Now, there's another benefit to doing that, and that is, and this is above the course material, but by doing things repetitively and efficiently without roadblocks, then if you're doing the same thing in a repetitive fashion, you're going to get better at it than if you perform that step once and then it's a month before you perform it again. You're likely to be distracted by the other tasks that you have. And so with the value stream, then we're trying to keep things flowing. Again, just like a creek or a river, so that we don't introduce delays. So that's our section on value stream. What questions might you have? Has anyone thought of something that they do in their life today that you could use this kind of a technique? Well,
It
let's
can be
get
applied to a lot of things.
right. Yeah, and that's one of the reasons that I really like this course, because while it is focused on DevOps, uh, I try to point out that these are things that you can use in other parts of your life as well.
I was gonna say, just like trying to find a job, if your resume isn't on point, even if you send it everywhere, you got to have that right before you start working on everything else.
Good point. Yeah. Yeah. If you don't have a good resume, then no matter how many you send out, it's unlikely that you're going to get an interview unless someone is really desperate to find someone to work for them. That's a great illustration. Thank you. So the second principle that we're going to look at is called the deployment pipeline. So looking at this pipeline picture, it looks much like a value stream, right? We've got a limited number of steps, but these are the steps that are used in many organizations in order to create new software. The pipeline steps that we're looking at here, the first is called the commit stage. And if you've got multiple programmers working to develop code that needs to work together, when they complete a section of their code, they will commit that code to the overall application. And that's what that commit stage is referring to. They've completed a section, not necessarily all of their code, but they've completed the code to provide a particular capability. The second step that we see in this deployment pipeline is that we need to test that code to see that it is working according to specifications. And if it is, then it moves to the third step, where we may do some manual quality assurance testing. So we used initially some automated testing. Automated testing is used because it can be done more quickly, but oftentimes there's some manual testing that needs to be done. And if we stay across the top of the line, then for manual testing, we have a step called user acceptance testing. That's what UAT stands for. And that's where either someone for the business or actually a customer would test the software. And if it passes that test, then it moves into production. Now, in this particular flow, coming from the manual QA testing, besides going to user acceptance testing, we can have a parallel process or a parallel step where we do capacity and load testing. So if we're expecting to have 100,000 users using this application, then we use load testing to simulate 100,000 people using this application at one time. And we see if it delivers the right outputs. And if it does, and the user acceptance testing passes, then we push the code into production. So that's the deployment pipeline. It's that series of steps. Could think of it as a value stream that we use in order to get new code put into production. So the idea behind the deployment pipeline is that we save resources by not starting the next steps before the previous ones are complete. And a second aspect to it is that it ensures that we produce a quality product. Because if changes are not performing well, then we're going to stop the pipeline and go back and fix them. And one of the important elements of the deployment pipeline is that we want to always have the system in a working condition. So if it doesn't pass the test, all of the tests, then we're not going to put it into production. If it fails here, we're going to go back and have the programmer make modifications so that the code can go through the process again. So the idea of the pipeline then is, as soon as we find that there's something that's not quite right, we send it back to the beginning. So the idea is that we can get the best flow when things are done right the first time. So then what are some challenges with the deployment pipeline? Or I'm sorry, we're not there yet. We're still talking about the pipeline itself. So with the pipeline, then we're able to accelerate the delivery of changes into the production environment. And we do that by using automation as much as possible. And at the same time, we need to create audit logs so that we can enable the monitoring of changes that are being made and collect measurements at each of the steps of the pipeline that can then help us to look for opportunities to improve the pipeline, much as we just talked about with value stream mapping. So what does this look like from a pictorial perspective? On the left-hand side, we've got the different steps that are involved in the pipeline. On the right-hand side, we see it as a flow diagram where we're going to flow from step to step. And in some cases, we're going to do things in parallel. But anytime we find a problem, we send it back to the beginning. So whether it passes both of these steps and then gets down here, if there's a failure down here, it goes back to the beginning. The idea is to, and some people call this failing fast. We want to identify as quickly as we can any issues so that we can take it back to the beginning and get it fixed. Now, if you're the person that's producing the new code at the beginning, that's beneficial to you, because while you would like to produce ideal code that works the first time and would pass all of the steps, if it doesn't, you want to know about it quickly, because you will still have in your mind, what was I thinking about when I created that code? And so you can then fix it more quickly, because you remember what you were just working on, as opposed to if we go through the pipeline and we get all the way to near the end before it comes back. And by then we may have been working on other code. And so it's going to take us more effort to fix it. So one of the concepts of the pipeline is to what we call fail fast, so that we can get it back and get it corrected if it's not right the first time. So that's how the pipeline operates. What questions might you have? Okay, now we're going to look at what are some challenges with the implementation of a deployment pipeline. The first is that while we just talked about the importance of automation to make the pipeline go fast, sometimes people use that concept to say that DevOps is all about automation, because it's through the automation that we make things go quickly. And it is through automation that we're able to deliver software faster. That is a true statement, but DevOps is much more than just automation. When an organization is beginning to use their pipeline, one of the challenges they're going to run into, we said that we wanted to use automated testing. Well, in order to create automated testing, you have to create code, much like the program itself, in order to execute the tests against the software that's been developed. And so as you're starting out, you're not going to oftentimes have automated tests because testing historically in a waterfall type project has been done manually. So so the solution to that is to spend the effort to create additional automated tests. And we point out here that the accumulated technical debt is due to be paid out sooner or later. So what we'd like to do is do it sooner because as we can increase our tests that are done, then our pipeline is going to operate more quickly. Now, once we've done that and we have our pipeline working pretty well, as our application gets larger and larger, then we run into a problem on the other side. And that is where we've created so many tests that it takes too long to run the tests. And so that becomes a roadblock. And the idea then is when you find that you have too many tests and it's slowing down your pipeline, then you need to think about and do a test impact analysis, as is pointed out here, so that we're doing the tests that are necessary to know that the changes that we've made are working correctly without doing every test that we've ever done on that application. And so in order to keep the pipeline moving, then we need to only do the tests that are necessary to make sure that the new functionality is working, but at the same time that we haven't broken some other aspect of the application. So it's kind of interesting how there's a yin and yang aspect to the pipeline and testing and automated testing. So what questions might you have on the deployment pipeline? Okay, then the next DevOps principle is version control. And we mentioned yesterday that there are different types of tools that can be used with DevOps, but version control is one of the key tools, one of the first tools if you're working to automate your pipeline that you're going to want to incorporate. And the idea of version control, if you think about this pipeline and you're continually running through the pipeline and adding new capabilities to your application, then you need to keep track of what versions of the application are working and which ones are we still working to provide additional capabilities. So in a version control system, then if we've got new code that we want to add to the application, we first check out the previous code, add the new code to it, and then we check in the new version of the code that includes both the previous code as well as the additional code. Once we do a check-in of the code, then we can put that code into an environment, an IT hardware environment called a build. And that's where we combine the software with the hardware. Once we've done the build, then we can deploy the software into the production environment. Now, this is a simplified diagram, but hopefully you get the idea that the way we use a version control system is to add code to the latest version of the application. Then we check it in, and that becomes the new code that the next person would check out, would be what we just checked in. We do the build, and then we deploy it to our customers. So this too is intended to show you that there's a flow with version control. So now, while I talked about the version control pertaining to the code, we use version control to also store not only the code, but also everything that's related to that particular application. So we would include things like the automated tests that are being done. We would include scripts. Scripts is a term for code that is available to be automated, that we can use for creating and modifying databases. What that means then is the script can identify or can create from scratch the fields in a database. So, for example, if we have a script for a database and it includes first name, last name, and address, well, that can be the ability to create those three fields can be created through a set of commands. And if you recall, yesterday we talked about, oh, now the word's escaping me. Infrastructure as code. Well, that's what a script, that would be a script. In this case, we're talking about infrastructure as a code for creating and modifying database. Then we can also have a script for performing the build functions. That's also infrastructure as code, as well as the environmental creation scripts. Then we can have deployment scripts. That means that we do the build, we create the environment, and then we deploy our application to the environment that's been created. We may also have some artifacts, some documents that we've created along the way in support of the application that we're using. We may also have some documentation that we've created or configuration files, or in today's environment, in a lot of cases, rather than building the code for a program from scratch, we will take advantage of what are called libraries, where we'll use code that's been created by someone else and simply add our code to that to make it perform functions above and beyond what the library was originally created to do. There are also some tools that we can use to for example, validate that the tests have run satisfactorily and automatically trigger uh, the build. And so those would also be stored in version control. So having said all that, the idea of version control is to have a single place where you've got all of the components that are necessary to create an application, and with the latest version of the application. You also store previous versions. But by having everything in one place, then you're avoiding a situation which often happened in the past where individual programmers would keep their code on their computer, their personal computer. And so if you needed an update to the code, you had to find that person, find it on their computer, or maybe they put it in a shared place. Well, the idea of version control is everyone is putting information about an application into the same system so that it's always available to anyone that needs it. So this just illustrates the previous slide from a pictorial perspective, where we see that the version control system is made up of all of these different other types of documents and programs, etc. So why is version control important? It enables us to control all of the parts of a system or an application. And instead of having to go to multiple places, we've got a single place. Um, Now, that also is important because it requires a change in the culture of that organizations are used to working in, where I've got my stuff, and if you want my stuff, you come to me and I'll give it to you. But through version control, it makes it easily accessible to anyone in the organization that needs to know not only the current version, but were some of the prior versions as well. So what are some benefits of version control? We can easily determine what was changed, when it was changed, and who changed it, because as something is being put into version control, it's going to carry that information. It also gives us the ability to restore any system or application to any particular point in the past. So if we put some new code into production and find that the system fails, we can very easily go back to version control and restore the system using not the latest version of the application, but the prior version of the application. And then the third benefit is that um, rather than the team members individually being responsible for making backups of their files, um, it enables the team to delete any files once they're done with them, or documents, because they're going to know that they're being kept in the version control system. And so they don't need to have their own copy, if you will. So those are the key aspects of version control. What questions might you have? Okay, hearing none. We've now looked at the value stream, we've looked at the deployment pipeline, and we've looked at version control. So we are probably a little more than halfway through our material for today. So why don't we take our break? And then we'll complete the material. We've got 2 more sections to cover today, and then the video that I mentioned earlier will show. So with that, why don't we take our break until 2:45, if that's okay for everybody? Give you about 17 minutes or so, 18 minutes.
Thanks.
Thank you.
Okay, thank you.
Welcome back, everyone.
Hello.
Hopefully you had a chance to stretch. Before we begin configuration management, any questions that you might have from the 3 sections that we covered so far? Okay, well, configuration management is a key component, which is why we call it a principle of DevOps. And here we recognize that DevOps restructures the management of the production environment. And the idea is that any changes that are made to any environment, including production, and when you say any environment, what do we mean? Well, typically in a pipeline, there are multiple environments that are created as we do different types of testing. So for example, we might create an environment where we can do the load testing. And we would want it to be like production, because if we're going to be checking that we have enough capacity, then it needs to be enough like the production environment that we would get an accurate test, just as an example. So the idea behind DevOps is that a change to any environment can only be made by scripts, which are stored in the version control system. So here we're tying together the idea of scripts, which we looked at being something that we stored in the version control system. And scripts are a form of infrastructure as code, which we talked about yesterday. So we talked about storing in the version control system libraries as being one of the things. And if we're going to need a new library in the test environment tomorrow, then an administrator would update the script for creating the test environment. They would test it and then put it in version control system. And when we use it tomorrow, then we will be using the latest version that includes the library that we need. So when we are creating environments using DevOps, we want to create those environments automatically when the deployment pipeline is running. So we're going to go from step to step in the pipeline using automated tools that will first create the step, do whatever is to be done, some type of testing during that step in the pipeline. And if that testing passes successfully, then we would automatically kick off the next environment. So the idea is that going through the pipeline is done with a lot of automation until we would find that there's a problem, and then we would be back to people that would be necessary to fix it if something isn't working correctly. So many of the previously described differences between DevOps and the way testing and development were done in the past. Excuse me, I'm having to sneeze, so I'm hopefully you're not hearing my sneeze.
Can't hear it, but bless you.
Thank you. So let me start over here. So the way DevOps is different from the usual practices that affected development and testing primarily, and only occasionally touched the interests of operations. Well, with configuration management, we need to reorganize the work of IT support and operations. And now, because we're using automation to create the environments, administrators that are part of the operations part of the organization will no longer need the rights to make changes in the production environment in the way they had done so before. So what in the heck does that mean? Well, in the past, before DevOps, um, once code was put into production, for example, if there was a security patch that needed to be applied to a server, the administrator of that server would apply that patch to the server directly. Well, now, because we're automating the pipeline, we don't want to do that anymore. We want to put that patch into our configuration management system. And so then the next time we run the pipeline, it will pick up that patch and push it into production, assuming that all of the tests would pass. So the idea is that we've now automated and gained control of exactly what's happening throughout the entire pipeline, including production. And so it's through that automation and the certainty that certain tests have been done that enables us to be more comfortable when we push new code into production than organizations were in the past. In the past, through what was called the change management process, oftentimes there was a lot of review and a lot of consternation that happened to make sure that all of the elements that needed to change, we were prepared to change. And now that it's automated, we don't need to worry about that anymore. And so that has made a dramatic change to the way IT operations behaves in the new environment. So the idea behind configuration management is to achieve the same benefits that are obtained from total version control, but now the beneficiaries of that are operations instead of the development side of the organization. And so all changes are controlled, can be quickly restored to a stable state, even if key members of the organization leave and their knowledge is now not lost, for example. And so configuration management is a key element and therefore a principle of DevOps. So that's our section on configuration management. Any questions on it? Okay, then our last principle is the definition of done. And this is a critical principle for DevOps because we completely changed the perception that people have of when work is done. The traditional approach was that employees that are working on a project, when they finish their tasks, they considered themselves, they considered the work done. And that's what we pay people to do. So as a couple of examples, if an analyst has defined the functional requirements for an application, then their work is done. If a developer has written the programming code in order to meet those requirements, then they are done with their part of developing an application. Likewise, if the testers test the application, they've done their part. So done then was in the eyes, if you will, of the person performing a particular task. So this concept then changes dramatically with DevOps. So one of the key principles then is that it's not when someone did their part of the work that it's done, but it's done or finished when the customer receives or starts to receive the value that they expected. So instead of the steps that are followed to create an application, each person did their part. When we think of things that way, we lose sight of the customer's perspective and the fact that value is not created until the customer gets what they were looking for. So then our definition of done means that the entire value stream has been followed through completely and up to the production environment. And only then will the work be considered done. So this principle may seem obvious, but it doesn't normally happen in an IT organization. It requires managerial changes to the way people perceive the work that's being done. So by making this change as part of DevOps, then we can enable the team that's working on an application to not focus on what they do, but to focus on the results or the value that they're delivering to their customer, which is the why we do it. So an example then is if people just have a limited responsibility for certain parts of the work. And if you think about if the guys go or a gals go purchase a suit, oftentimes you'll meet with a tailor that will determine where the buttons need to be based on your particular build. So the idea then is that by having a collective responsibility where the work's not done until the customer gets value, then the idea of putting on the buttons in a certain place changes from I put the buttons on to the end result that the customer is looking for, that the suit will fit. So hopefully that illustration then shows you the difference then between how done might have been perceived in the past versus the way it is viewed with DevOps. So that finishes our second unit. Welcome, Daniel.
Thank you.
So we have exercises for the second module, just like we did the first, and we'll let you complete those. But before we finish for today, I mentioned that I wanted to show you a video to kind of help put in perspective what it is that we're trying to do with this thing we're calling DevOps. So it is a video that was created by Spotify in two different parts. We'll look at the first part today and then the second part tomorrow. So let me switch over to the video, and if by chance you have any trouble hearing the video, put something in chat and I'll stop the video and we'll figure out what's going on. But hopefully that won't be an issue. So bear with me for a moment while I switch things over.
One of the big success factors here at Spotify is our agile engineering culture. Culture tends to be invisible. We don't notice it because it's there all the time, kind of like the air we breathe. But if everyone understands the culture, we're more likely to be able to keep it and even strengthen it as we grow. So that's the purpose of this video. When our first music player was launched in 2008, we were pretty much a Scrum company. Scrum is a well-established agile development approach, and it gave us a nice team-based culture. However, a few years later, we had grown into a bunch of teams and found that some of the standard Scrum practices were actually getting in the way. So we decided to make all this optional. Rules are a good start, but then break them when needed. We decided that Agile matters more than Scrum, and Agile principles matter more than any specific practices. So we renamed the Scrum Master role to Agile Coach, because we wanted servant leaders more than process masters. We also started using the term squad instead of Scrum team, and our key driving force became autonomy. So what is an autonomous squad? A squad is a small, cross-functional, self-organizing team, usually less than 8 people. They sit together and they have end-to-end responsibility for the stuff they build. Design, commit, deploy, maintenance, operations, the whole thing. Each squad has a long-term mission, such as make Spotify the best place to discover music, or internal stuff like infrastructure for A/B testing. Autonomy basically means that the squad decides what to build, how to build it, and how to work together while doing it. There are, of course, some boundaries to this, such as the squad mission, the overall product strategy for whatever area they are working on, and short-term goals that are renegotiated every quarter. Our office is optimized for collaboration. Here's a typical squad area. The squad members work closely together here with adjustable desks and easy access to each other's screens. They gather over here in the lounge for things like planning sessions and retrospectives. And back there is a huddle room for smaller meetings or just to get some quiet time. Almost all walls are whiteboards. So why is autonomy so important? Well, because it's motivating, and motivated people build better stuff. Also, autonomy makes us fast by letting decisions happen locally in the squad instead of via a bunch of managers and committees and stuff. It helps us minimize handoffs and waiting so we can scale without getting bogged down with dependencies and coordination. Although each squad has its own mission, they need to be aligned with product strategy, company priorities, and other squads. Basically, be a good citizen in the Spotify ecosystem. Spotify's overall mission is more important than any individual squad. So the key principle is really be autonomous, but don't sub-optimize. It's kind of like a jazz band. Although each musician is autonomous and plays his own instrument, they listen to each other and focus on the whole song together. That's how great music is created. So our goal is loosely coupled, but tightly aligned squads. We're not all there yet, but we experiment a lot with different ways of getting closer. In fact, that applies to most things in this video. This culture description is really a mix of what we are today and what we are trying to become in the future. Alignment and autonomy may seem like different ends of a scale, as in more autonomy equals less alignment. However, we think of it more like two different dimensions. Down here is low alignment and low autonomy, a micromanagement culture. No high-level purpose, just shut up and follow orders. Up here is high alignment, but still low autonomy. So leaders are good at communicating what problem needs to be solved, but they're also telling people how to solve it. High alignment and high autonomy means leaders focus on what problem to solve, but let the teams figure out how to solve it. What about down here then? Low alignment and high autonomy means teams do whatever they want and basically all run in different directions. Leaders are helpless and our product becomes a Frankenstein. We're trying hard to be up here. Aligned autonomy. And we keep experimenting with different ways of doing that. So alignment enables autonomy. The stronger alignment we have, the more autonomy we can afford to grant. That means the leader's job is to communicate what problem needs to be solved and why. And the squads collaborate with each other to find the best solution. One consequence of autonomy is that we have very little standardization. When people ask things like, which code editor do you use? Or how do you plan? The answer is mostly, depends on which squad. Some do Scrum sprints, others do Kanban. Some estimate stories and measure velocity, others don't. It's really up to each squad. Instead of formal standards, we have a strong culture of cross-pollination. When enough squads use a specific practice or tool, such as Git, that becomes the path of least resistance, and other squads tend to pick the same tool. Squads start supporting that tool and helping each other, and it becomes like a de facto standard. This informal approach gives us a healthy balance between consistency and flexibility. Our architecture is based on over 100 separate systems coded and deployed independently. There's plenty of interaction, but each system focuses on one specific need, such as playlist management, search, or monitoring. We try to keep them small and decoupled with clear interfaces and protocols. Technically, each system is owned by one squad. In fact, most squads own several. But we have an internal open source model, and our culture is more about sharing than owning. Suppose Squad 1 here needs something done in System B, and Squad 2 knows that code best. They'll typically ask Squad 2 to do it. However, if Squad 2 doesn't have time, or they have other priorities, then Squad 1 doesn't necessarily need to wait. We hate waiting. Instead, they're welcome to go ahead and edit the code themselves, and then ask Squad 2 to review the changes. So anyone can edit any code, but we have a culture of peer code review. This improves quality and, more importantly, spreads knowledge. Over time, we've evolved design guidelines, code standards, and other things to reduce engineering friction, but only when badly needed. So on a scale from authoritative to liberal, we're definitely more on the liberal side. Now, none of this would work if it wasn't for the people. We have a really strong culture of mutual respect. I keep hearing comments like, "My colleagues are awesome." People often give credit to each other for great work and seldom take credit for themselves. Considering how much talent we have here, there is surprisingly little ego. One big aha for new hires is that autonomy is kind of scary at first. You and your squad mates are expected to find your own solution. No one will tell you what to do. But it turns out, if you ask for help, you get lots of it, and fast. There's genuine respect for the fact that we're all in this boat together and need to help each other succeed. We focus a lot on motivation. Here's an example, an actual email from the head of people operations. "Hi everyone, our employee satisfaction survey says 91% enjoy working here and 4% don't." Now that may seem like a pretty high satisfaction rate, especially considering our growth pain. From 2006 to 2013, we've doubled every year and now have over 1,200 people. But then he continues, "This is of course not satisfactory and we want to fix it. If you're one of those unhappy 4%, please contact us. We're here for your sake and nothing else." So good enough isn't good enough. Half a year later, things had improved and satisfaction rate was up to 94%. This strong focus on motivation has helped us build up a pretty good reputation as a workplace. But we still have plenty of problems to deal with. So yeah, we need to keep improving. Okay, so we have over 50 squads spread across 4 cities. Some kind of structure is needed. Currently, squads are grouped into tribes. A tribe is a lightweight matrix. Each person is a member of a squad as well as a chapter. The squad is the primary dimension, focusing on product delivery and quality, while the chapter is a competency area, such as quality assistance, agile coaching, or web development. As squad member, my chapter lead is my formal line manager, a servant leader focusing on coaching and mentoring me as engineer, so I can switch squads without getting a new manager. It's a pretty picture, huh? Except that it's not really true. In reality, the lines aren't nice and straight, and things keep changing. Here's a real-life example from one moment in time for one tribe. And of course, it's all different by now. And that's okay. The most valuable communication happens in informal and unpredictable ways. To support this, we also have guilds. A guild is a lightweight community of interest, where people across the whole company gather and share knowledge within a specific area. For example, leadership, web development, or continuous delivery. Anyone can join or leave a guild at any time. Guilds typically have a mailing list, biannual conferences, and other informal communication methods. Most organizational charts are an illusion, so our main focus is community rather than hierarchical structures. We've found that a strong enough community can get away with an informal, volatile structure. If you always need to know exactly who is making decisions, you're in the wrong place. One thing that matters a lot for autonomy is how easily can we get our stuff into production. If releasing is hard, we'll be tempted to release seldom to avoid the pain. That means each release is bigger and therefore even harder. It's a vicious cycle. But if releasing is easy, we can release often. That means each release is smaller and therefore easier. To stay in this loop and avoid that one, we encourage small, frequent releases and invest heavily in test automation and continuous delivery infrastructure. Release should be routine, not drama. Sometimes we make big investments to make releasing easier. For example, the original Spotify desktop client was a single monolithic application. In the early days, with just a handful of developers, that was fine. But as we grew, this became a huge problem. Dozens of squads had to synchronize with each other for each release, and it could take months to get a stable version. Instead of creating lots of process and rules and stuff to manage this, we changed the architecture to enable decoupled releases. Using Chromium Embedded Framework, the client is now basically a web browser in disguise. Each section is like a frame on a website, and squads can release their own stuff directly. As part of this architectural change, we started seeing each client platform as a client app and evolved 3 different flavors of squads: client app squads, feature squads, and infrastructure squads. A feature squad focuses on one feature area, such as search. This squad will build, ship, and maintain search-related features on all platforms. A client app squad focuses on making release easy on one specific client platform, such as desktop, iOS, or Android. Infrastructure squads focus on making other squads more effective. They provide tools and routines for things like continuous delivery, A/B testing, monitoring, and operations. Regardless of the current structure, we always strive for a self-service model. Kind of like a buffet. The restaurant staff don't serve you directly. They enable you to serve yourself. So we avoid handoffs like the plague. For example, an operations squad or client app squad does not put code into production for people. Instead, their job is to make it easy for feature squads to put their own code into production. Despite the self-service model, we sometimes need a bit of sync between squads when doing releases. We manage this using release trains and feature toggles. Each client app has a release train that departs on a regular schedule, typically every week or every 3 weeks, depending on which client. Just like in the physical world, if trains depart frequently and reliably, you don't need much upfront planning. Just show up and take the next train. Suppose these 3 squads are building stuff, and when the next release train arrives, features A, B, and C are done, while D is still in progress. The release train will include all 4 features, but the unfinished one is hidden using a feature toggle. It may sound weird to release unfinished features and hide them, but it's nice because it exposes integration problems early and minimizes the need for code branches. Unmerged code hides problems and is a form of technical debt. Feature toggles let us dynamically show and hide stuff in test as well as production. In addition to hiding unfinished work, we use this to A/B test and gradually roll out finished features. All in all, our release process is better than it used to be, but we still see plenty of improvement areas, so we'll keep experimenting. This may seem like a scary model, letting each squad put their own stuff into production without any form of centralized control. And we do screw up sometimes, but we've learned that trust is more important than control. Why would we hire someone who we don't trust? Agile at scale requires trust at scale, and that means no politics. It also means no fear. Fear doesn't just kill trust, it kills innovation, because if failure gets punished, people won't dare try new things. So let's talk about failure. Actually, no. Let's take a break. Get on your feet, get some coffee, let this stuff sink in for a bit, and then come back when you're ready for part 2, okay?
Okay, well, that video I'd like to share with you. It's not part of the course officially. And we talk some about culture in this class, but hopefully some of the ideas or some of the concepts that we're sharing with you in this class, you saw lived out, if you will, in that video. And as I mentioned, we'll watch part 2 tomorrow. But we have finished our material for today. Daniel's, you'll have to watch the recording to see what we learned about. And also, thank you for sending your exercises. I will send you the official answers to the exercises a little bit later. So, with all that we've covered, what questions or comments might you have? Well, hearing none, then remember to complete the exercises for Unit 2, and we will pick up the class tomorrow at 1 o'clock. Thank you.
I have a
Thanks, John.
question, just
Okay.
real quick, about, did you send out the recordings from yesterday? The recording,
Ben sent it out.
Okay, all right. I just wanted to make sure I had it. That's it. I don't have any more questions.
Okay,
All right,
good.
thank you.
okay, thank you.
Thanks, John.
Sure. Daniel, do you have any questions?
No, I'm good. I will watch the video and send my assignment hopefully in the morning.
Okay, that's terrific. Thank you.
You're welcome. Thank you.
Bye now.